Hey guys, and welcome back to day 8 of the 10-day algebra series. Today we are going over how to solve systems of linear equations. The first strategy we're going to be looking at today is graphing, which if you haven't watched the video before this, episode 7, we talk about the different forms of lines and how to graph them. So in this first example, I'm given two lines in slope-intercept form. So as a little refresher, our y-intercept is that number at the end, so -2 is where we're starting our line, and then we're using our slope as a +5, which would be up 5 over 1 to create our line. Then same thing with our second line. This time our y-intercept is at a +4, so we would start our line with a point at +4 on our y-axis, and then since there's no number in front of x, that means there's an imaginary 1, and that is a -1 over 1. So you're going to see here I have a slope of -1, and to solve systems of linear equations, you're wanting to know what they have in common. So where these two lines cross is going to be your solution. Remember, your x is that horizontal line, so it's looking like our x is at a +1 where those cross, and then your y is that vertical line, which in this example is at a +3. So we'd have an answer of x is +1, y is +3. These next two are in standard form, so you could use our standard form strategy, or you could just turn it into slope-intercept form by getting y by itself, which is the strategy I chose to do here. If you want to see how we would graph these in the form they already are in, make sure you go back and watch that last video. So I'm starting by subtracting 3x from both sides so that I'm just left with 4y on the left, and then dividing everything by 4 so that it's just y equals. Then same thing as that first example, I'm starting at a +4 and I'm using my slope of -3 over 4, so down 3 to the right 4, and then connecting those 2 points to make my line. Repeating that same thing for that second equation, so I'm subtracting x from both sides, and then multiplying everything by a -1 to get that to be a +y. All right, then we get that our y-intercept's at -3, so going through our y line at -3 and a slope of +1 over 1. Right, then you're going to find where they cross. That is going to be your solution, which in this example, it's looking like our x is at a +4 and our y is at a +1. And if you have two lines with the same slope, they'll end up being parallel and never crossing, so they do not have a solution. All right, and my next two strategies are for more of my algebra lovers, starting with substitution. If you're ever given y equals or x equals, you can go ahead and just plug that in to the other equation, right? Because you'll notice once I do that, I'm only going to be left with x's, so then I can solve. Right now, I have x and y in both equations, which we cannot solve for. But notice here, instead of y in that first equation, I'm replacing it with what they tell me y equals, -6x minus 9. And then we know that's going to equal -10. From here, I'm left with only x's, so I can go ahead and solve for x. All right, so first of all, I see some parentheses where I need to distribute. So 4 times my -6x will get me -24x. 4 times a -9 is going to get me -36. All right, then I'm just dropping down everything below. I have some like terms I can combine. So I'm going to get a -26x there. And then to get rid of that -36, I'm going to add 36. Have to do that to both sides of my equation, so that I get -26x is 26, and then just divide by that -26 to get that x is -1. Once you have one of the solutions, you can choose either one of those equations to plug back into to get your y. So we know y equals -6 times our x, which we just found out is -1, minus 9. -6 times -1 would get us a +6. Minus 9 is going to get us -3. So we end up with a solution of -1, -3. Just like anytime you're solving an equation, you can check your answer by plugging your answer back in and seeing if it works. So in both of those equations, instead of x, you're going to replace it with -1. Instead of y, you're going to replace it with -3. And if it works out to get you the correct answer, then you know that it checks out, it works. Now we could use that same strategy for something like this second example we have here, except for notice we don't have that x equals something or that y equals something. So we just have to manipulate one of the equations a little bit so that it is just x equals or y equals. So I'm going to make this y equals by adding 2x to both sides of my equation so that it's y equals 2x plus 2. Then I can do just the exact same thing I did on that first one. Instead of y, I'm going to replace it with 2x plus 2 in that first equation. So rewriting that first equation, -2x plus 4, and then instead of y, it's 2x plus 2 equals -10. From here, you're going to distribute that 4 onto both things in the parentheses. You're going to combine your like terms to get 6x, get rid of that 8 to get that 6x is -18, divide both sides by 6 to get that your x is -3. Then from there you can plug into either equation to get your y, but easiest way to plug in is into y equals 2 times our x, which is -3, is -6, plus 2 gets us that our y is -4. Now if that strategy makes sense to you, go ahead, you can always use that. However, in this example, since we have two of the terms matching up like this, I would actually argue that you should use elimination method instead. Elimination is by either adding the two equations together or subtracting the two equations so that one thing is eliminated. Like in this example, since those two things match up, if I subtract them, they're just going to cancel each other out. And now I have to subtract all my other terms. So 4y minus a y would be 3y, -10 minus 2 would be -12, and then just solve for y. So divide both sides by by 3 to get that y is -4, which if you remember, that's what we got before when we did this with the other strategy. Then same thing, once you have one of your solutions, just plug it in to get the other. So instead of y, I'm going to replace it with -4, and then I'm going to solve for my x. So I'm going to add 4 to both sides to get that -2x is 6, and then divide both sides by -2 to get that x is -3, which again, remember when I used substitution, I did get that answer of -3, -4, just like I did with this elimination method. So that was when I had the same term. I'm going to subtract them. However, in this next example I have opposite terms, so I would want to add them because 9x and a -9x combined are going to cancel. However, notice in this example, my y's also cancel, so I'm left with nothing on the left side, so 0, and 11 minus 9 or plus a -9 is going to get me 2, which is not true. So that means there's no solution. So if you were to graph this, this would be two lines with the same slope. They're never going to cross paths, so they do not have a solution. And on to my last example here, notice nothing's going to cancel out right away by adding or subtracting. However, you could take that first equation times 3, so taking everything times 3 to get us 6x plus 6y equals a -12, and then notice our x's will cancel out. All right, so you can always multiply one of these by a number, but you have to multiply everything by it to then make them have this elimination method work. All right, so notice when I did that, I was left with 9y equals a -9, which then to solve for y, we just divide both sides by 9 to get that y is -1. Then, just like we've been doing before, once you have one solution, you can plug it into either one of those to get the other solution. So we plug in y is -1, and then we solve for x, getting 2x equals -4, divide by 2 to get that x is -2. It's important to remember that you can use any 3 of these strategies for any of these problems. It just depends what makes the most sense to you. And if you made it this far, thank you so much for watching. Please give this video a thumbs up. Comment down below which strategy you ended up liking the most, as well as any questions you would like to see on my TikTok or YouTube shorts. I'll see you in the next one.